Class 9, Chapter 1, Number Systems, Exercise 1.3, page number 14. He is asking us to convert the given rational number into decimal form, and he is asking us to say which type of decimal it is. So let us take the first problem. It is 36 by 100. Before starting the problem, I want to say a few things. First of all, when any rational number is in P by Q form, there are two possibilities when you divide. When you convert into decimals, there are two possibilities. One, it can be terminating decimal, or it can be non-terminating repeating decimal. So when it is in P by Q form, only two possibilities. Either it can be terminating decimal or it can be non-terminating repeating decimal. If you have any decimal form like this, if it is ending, then you say it is a terminating decimal. If the decimal form is repeating and not ending, then we can say non-terminating repeating decimal. Two possibilities are there. You can divide and finally tell which one. Okay, there is no chance of getting non-terminating non-repeating decimal. Non-terminating non-repeating decimal is not possible. Why? Because non-terminating non-repeating is irrational. It cannot be expressed in P by Q. So this is P by Q. It can be terminating, it can be non-terminating repeating. That's it. So let us divide and check what type of decimal it is. Okay. So I am dividing 36 with 100. All of you listen carefully. 36 is divided by 100. 36 is a smaller number. I want a 0. So 0 point. Put a point, you will get 1 0. 100 threes are 300. Subtract. With this point, you can get one more 0. 100 six are 600. Remainder 0. So 36 by 100 is equal to 0.36. It is a terminating decimal. So write down terminating decimal form. Terminating decimal form. Okay. I want to tell one more thing over here. Whenever you have P by Q form, if you factorize the denominator, if at all you factorize the denominator, 250s are 225s are 5 5s are 5 1s are. In the factorization of the denominator, if you are getting 2s and 5s, if you are getting 2s and 5s, or only 2s, only 5s, in that case you will get terminating decimal. Along with 2 and 5, any other prime number like 3, 7, 11, 13, 17, 19, any other prime number is involved, then it will be non-terminating repeating decimal. डिनोमिनेटर को फैक्टराइज करने के बाद 2 और 5 आया या ओनली 2 आया, ओनली 5 आया, तो वो डेसिमल फॉर्म होगा टर्मिनेटिंग डेसिमल फॉर्म. 2 और 5 के साथ कोई और प्राइम नंबर आया तो वो होगा नॉन terminating repeating decimal. So this is the concept. So first problem is done. I have divided and mentioned what type of decimal it is. Let us go to the second bit. So the second bit is 1 by 11. Let us divide 1 and 11. So put a point, you will get 0. Still 10 is smaller than 11. This number is smaller than 11. So you need to put 1 0 and put one more 0. Now you got 100 here. 11 nines are 11 nines are 99. Subtract 1. With the help of point you can put 1 0. 10 is smaller, so put one more 0 so that it becomes 100. 11 nines are again 11 nines are 99. Subtract 1 will remain. With the help of decimal point, put 0. 10 is smaller, put 1 0. It will become 100. 11 nines are 99. So it will continue. So you can actually 1 by 11. Decimal form of 1 by 11 is 0.090909, so on. You can write 0.09 bar. Why? Because 09 is repeating. So the decimal form is non-terminating repeating decimal form. Okay, so whenever denominator, if denominator is not having, when you factorize denominator, if you are getting a prime number other than 2 and 5, apart from 2 and 5, if you are getting any prime number in the factorization of denominator, then that will be non-terminating repeating decimal. Got it? Third bit is 4 1 by 8. Let us convert this into improper fraction. 4 8s are 32, 32 plus 1, 33 by 8. So now divide 33 by 8. Now let us divide 33 by 8. 8 4s are 32. One reminder, put a point, get 0. 8 1s are 8. 2 is the remainder. With this point we can put 1 0. 8 2s are 16. 4 is the remainder. With this decimal point we can put 0. 8 5s are 40. 0 is the remainder. Now 33 by 8 is nothing but 4.125. So 4 1 by 8 is 33 by 8 and the decimal form is 4.125. It is a terminating decimal form. Terminating So for your information, the denominator is 8. When you factorize denominator, 2 4s are, 2 2s are, 2 1s are, we are getting all 2s. So when you have 2s in the denominator, you will get terminating decimal. Even if you have 5s in the denominator, after factorization, you will get terminating decimal. Combination, if you have 2s and 5s also, you will get terminating decimal. Apart from 2 and 5, any other prime number comes like 3, 7, 11, any other prime number comes, then it will be non-terminating repeating decimal. Please keep this in mind. The next bit is 3 by 13. Let us divide. 3 is smaller number, so I will put a point, 0 point. I will take 1 0. 13 twos are 26. 4 subtract, you will get 4. Put a point. 13 threes are 39. Subtract, you will get 1. With this point, you can take 0. Still, the number is smaller. Put a 0. It will become 100. 13 sevens are 91. Subtract, 9 remains. With this point, put a 0. Now 13 sixes are 78. You will get 12. With this point, get 1 0. 13 7. 13 nines are 117. 3 is a reminder. Put a point, you will get 0. 13 threes are, 13 twos are 26. 4 reminder. With the point, I am putting 0. 13 threes are 39. So if you observe carefully, this whole thing is again repeated. We are again getting 2, 3, 0, 7, 6, 9. So we need not continue the division. Directly write down 3 by 13 is equal to 0.23076923 so on, which is nothing but 0.230769 bar. Okay, what type of decimal is this? It is a non-terminating repeating decimal. Please copy it down. So last bit, sorry, we have one more bit, 2 by 11. I'm going to divide 2 by 11 here. 2 divided by 11, put a point, you will get 0. 11 ones are 11, 9 is remainder. With this point, I can put 0. 11 eights are 88, 2 remainder. With this point, 0. 11 ones are 11. 9 is the remainder. Put a point, 0. 11 eights are 88. Again, 2 is the remainder. So we are actually getting 0.1818. So 2 by 11 is equal to 0.1818, which is nothing but 0.18 bar. It is a non-terminating repeating decimal. That's it. So the next bit is 329 by 400. Let us divide 329 divided by 400. 329 divided by 400. Put a 0, put a point, get 0. Now 408 za, 3200. So 90 remaining. With this point, you can get one more 0. 402 za 800. 100 remaining. With this point, we can get 0. 402 za 800. 200 is remaining. With this point we can get 0. 400 5s are 2000. 0 is the remainder. So our answer 329 by 400 is equal to 0.8225. It is a terminating decimal. We got terminating decimal. Why? Because on factorizing the denominator, if you factorize 400, you will get only 2s and 5s. You will not get any other prime number. That is the reason we got terminating decimal. Class 9 Maths, exercise 1.3, second question. In the question, 1 by 7 value is given. Decimal form of 1 by 7 is given. And he is asking us to find decimal form of 2 by 7, 3 by 7, 4 by 7, 5 by 7, and 6 by 7 without dividing, without any division. You should not divide, but you should get the decimal form. So how to get decimal form of these rational numbers without division, I will explain you. First of all, write down what is given in the question. It is given that 1 by 7 is equal to 0.142857, isn't it? I'm taking 1 by 7 value. Now he's asking me to find 2 by 7. To find 2 by 7, I can write 2 by 7 as 2 into 1 by 7. 2 into 1 by 7 value, already we have 0.142857. Multiply and get your answer. Got it? Just multiply and get your answer. On multiplication, we get 0.285714. That's it. If you notice here, when you are having 2 by 7, from here it is starting 285714. Okay. Now let us go to the second bit. He is asking us to find next 3 by 7. Let us do 3 by 7 part in the next page. 3 by 7 can be written as 3 into 1 by 7. 3 into 1 by 7 value is given in the question itself as 0.142857. Okay, this is the value of 1 by 7. I have substituted 1 by 7 value. Now I need to multiply to get 3 by 7. Please multiply and tell me the answer. On multiplying, we get 0.48571. So 3 by 7 decimal form is this. Without any division, we got our answer. Now he's asking us to find 4 by 7, 5 by 7, and 6 by 7. In the same way we can get these values. I will show in the next page. For example, if you want 4 by 7, you should multiply 4 into 1 by 7. Okay. Now 1 by 7 value is given in the question itself, and it is 0.142857. 0.142857. Just multiply these two to get your answer. On multiplying, we get 0.571428. Don't forget to the put bar. In the previous case also, please try put bar. It is non-terminating repeating decimals, so you have to maintain the bar. I forgot to put bar over here. Please note and keep the bar. Now 5 by 7. 5 by 7 can be written as 5 into 1 by 7, and we have 1 by 7 value with us, and the 1 by 7 value is 0.142857. On multiplication, we get 0.714285 bar. Don't forget to put the bar. And lastly, he's asking us to find 6 by 7, which is nothing but 6 into 1 by 7. 6 into 1 by 7 value is given in the question itself. On substituting 1 by 7 value and multiplying with 6, we get 0.857142 bar. Got it? Like this, we got all the values starting from 2 by 7, 3 by 7, we got 4 by 7, 5 by 7 and 6 by 7. See, I will tell you the logic here. This value is given as 0.142857. Now 2 by 7 starts with 2. You will get 0.285714. Got it? 3 by 7. 3 by 7 starts with 4. 0.428571 starts with 4. Rest of the numbers remain same. You should put bar. Starts with 4. 428571. Next number 4 by 7. Take ascending order. Okay. After 4, 5 will come now. After 4, 5 will come. So start with 5. 0.571428 will be the answer. For 5 by 7, the next number after 5 is 7. So you will get 0.714285. 714285. Okay, then to find 6 by 7, which is greater than 7, what is the number greater than 7? 8, na? Start with 8. 0.857142. Put bar in all the cases. So I hope you understood. ध्यान से देखिए, 2 by 7 रहा तो 2 से स्टार्ट करिए, 3 by 7 2 से बड़ा नंबर से स्टार्ट करिए, 4 by 7 4 से बड़ा नंबर जो भी है वहां से स्टार्ट करिए, 5 by 7 5 से बड़ा नंबर जो भी है वहां से स्टार्ट करिए, 6 by 7 7 से बिगर नंबर असेंडिंग ऑर्डर में लिखा गया तो 2 के बाद 4, 4 के बाद 5, 5 के बाद 7, 7 के बाद 8. ये है असेंडिंग ऑर्डर. 2/7 2 से स्टार्ट होगा, 3/7 4 से स्टार्ट होगा, 4/7 5 से स्टार्ट होगा, 5/7 7 से स्टार्ट होगा, 6/7 8 से स्टार्ट होगा. रेस्ट ऑफ द नंबर सेम रहेगा. Actually, in the question, 1/7 value is given as 0.142857. So when you are trying to do 2/7, 3/7, 4/7, 5/7, and 6/7. I will explain. I will give you one trick. First of all, leaving one, write down the rest of the numbers in ascending order. We have 4, 2, 8, 5, 7, ascending order. Smallest is 2, next 4, next 5, next 7, and the last bigger one is 8. This is the ascending order of the numbers excluding 1. Okay, so 1/7 value is 0.14257. I need to put here bar. I'm forgetting bar. So what I want you to do is arrange these numbers excluding 1 in ascending order. We get 2, 4, 5, 7, 8. Small to big. So after 1/7, you will get 2/7. Take the smallest number and write rest of the numbers starting from 2. Start with 2. What I mean to say is 2 से start करो. 2 के बाद के numbers लिखो. 8 लिखो, 5 लिखो, 7 लिखिए, 1 4 लिखिए. So this is your 2/7. Now to get 3/7, 2 done. What is the next bigger number? 2 के बाद next bigger number 4 है, तो 4 से start होगा. 0.4 4 से start होगा. 4 के बाद क्या क्या नंबर्स आ रहे सीरियल ऑर्डर में आप मेंटेन करिए. बार लिखना मत भूलिए, सॉरी. 4 के बाद 2, 8, 5, 7 और ये दो नंबर्स भी लिखिए 1 4 बार. दिस इज योर आंसर. नेक्स्ट 4/7, 4 done. Next bigger number is 5. So 4/7 will start with 0.5. 5 के बाद के नंबर सीरियल ऑर्डर में लिखिए. So here 5 से स्टार्ट करिए. 5 के बाद 7 आ रहा तो 7 लिखिए. 7 के बाद 1 4 2 8 लिखिए. 1 4 2 8 बार मत भूलिए. 5/7 5 यूटिलाइज हो गया. 5 से बढ़कर नंबर 7 है. सो 0.7 7 से स्टार्ट कर रहे हैं आप. 0.77 के बाद के नंबर्स लिखना है. व्हाट ऑल यू आर गेटिंग आफ्टर 7 you write on 1 4 2 8 5. 1 4 2 8 5 will come and put the bar. And for 6/7, the next bigger number 8, you have to start with 8 and write down in order what all numbers you are getting after 8. After 8 I am getting 5 7 and then I am getting 1 4 2. Put the bar. In this way we can get all the values. I hope you understood this. Class 9 Maths Exercise 1.3, third question, first bit. He is asking us to convert this into P by Q form. So there is a specific method to convert this decimal into P by Q form. I will explain in the next page. First of all, take the given decimal as X. Whatever decimal given, you have to take it as X. Now when you remove the bar, you will be getting 666, so on. It will continue, it is repeating. This is your equation 1. Now you have to check bar is for how many digits. If it is written for one number, one integer or one digit, then we say that periodicity is 1. If it is bar is given for 2 digits, then periodicity will be 2. If bar is given for 3 digits, periodicity is 3. Now in this case, bar is given for only one number, so periodicity is 1. So when periodicity is 1, you will be multiplying with 10 on both sides. If periodicity is 2, you will be multiplying with 100 on both sides. If periodicity is 3, you will be multiplying with 1000 on both sides. Depending upon how many digits are having bar, you should decide what to multiply. Here, I observe that bar is given for 1 digit, so multiplying by 10 on both sides. So left hand side 10 is multiplied in the same way. Right hand side also 10 is multiplied. 10 into x is 10x. On multiplying with 10, the decimal point will move forward 1 digit. Okay? 0.6 will become 6.66666, so on, and this is your second equation. Okay, so when you are multiplying with 10, point shifts 1 digit ahead. Guess what happens when you multiply with 100? It will shift 2 digits ahead. Okay, so now I got both the equations. Now I will be subtracting both the equations in the next page. Equation 2 minus equation 1. First of all, write down equation 2. What is equation 2? 10x is equal to 6.666, so on. 10x is equal to 0.66666, so on. And what is equation 1? Equation 2 minus equation 1. Write down equation 1. X is equal to 0.666 is the equation 1. X is equal to, sorry, 10, I made a mistake over here. 10x is equal to 6.666. X is equal to 0.66666, so on. Okay. Now we are subtracting. 10x minus x is 9x. On subtracting 6 and 6, I get 0. 6 minus 6, 0. 6 minus 6, 0. 6 minus 6, 0. 6 minus 6, 0. point. Here I will be getting 6. There is no value for zeros after decimal point. So you can neglect all these zeros and write down just 6. X is equal to 6 by 9. 3 twos are, 3 threes are. So I got P by Q form. What is P by Q form? 2 by 3. So I have converted 0.6 bar into P by Q form, and my answer is 2 by 3. You can even verify this by dividing 2 by 3. Divide 2 by 3, you will get 0. Put a 0, 3 6 are 18. Now here 2 is reminder, put 0, 3 6 are 18. 2 reminder, put one more 0, 3 6 are 18. 2 is the reminder. So 2 by 3 is equal to 0.666, so on. 2 by 3 is equal to 0.6 bar. It is verified. Both are equal. In the examination, no need to verify. You can end your answer over here, converting the decimal into P by Q form. So the second bit is 0.47 bar. 7 is having bar. Let us take x is equal to 0.47 bar. On removing the bar, you will get 0.4. 7 will continue. This is your equation 1. Bar is written for one number, so periodicity is 1. So you have to multiply both sides by 10. So on the left hand side 10 is multiplied. On the right hand side also 10 is multiplied. 10 into x is 10x. On multiplying with 10, the point will shift one digit ahead. You will get 4.77777, so on. This is your equation 2. Now subtract equation 2 and equation 1. Subtract both. What is equation 2? You can check. 10x is equal to 4.7777, so on. And equation 1 is x is equal to 0. X is equal to 0.4777, so on. Okay. Now here 7 minus 7 is 0. 7 minus 7, 0, 0, 0. 7 minus 7, 7 minus 1. You will get zeros. So here 7 minus 4 is 3. 4 minus 0 is 4. 10x minus x is 9x. Now there is no value for zeros after decimal point. You can neglect all these zeros. So you will get 9x is equal to 4.3. 9x is equal to what? 4.3. X is equal to 4.3 by 9. Now, if you remove the decimal point, you will get 43 by 90. So This cannot be further simplified. So your answer is 43 by 90. You can verify by dividing 90 and 43. On dividing, you will definitely get 0.47 bar. So the next bit is 0.001. Let us write. Let us take x is equal to 0.001 bar. On removing the bar, we will get 0.001, 001, 001, 001. It will repeat like this. This is your equation 1. Bar is for 3 numbers. So periodicity is 3. You have to multiply by 1000 on both sides. 1000 on both sides. Multiply 1000 into x is equal to 0.001, 001, 001, so on into 1000. On multiplying with 1000, this point will shift 3 digits ahead. So 1000x is equal to 1.001, 001, 001, so on. This is our equation 2. As we are having 3 zeros, it will shift 3 numbers ahead and point will settle here. That's why 1.01, 001, 001 will come. So now we have to subtract both the equations. Equation 2 minus equation 1. What is equation 2? 1000x is equal to 1.001, 001, 001, so on. This is equation 2. What is equation 1? X is equal to 0.001, 0.001, 001, 001, so on. Now subtract. 1000 minus x is 999x. 1 minus 1 is 0. 0 minus 0, 0, 0. 1 minus 1, 0, 0, 0, 0, 0, 0. 1 minus 0 is 1. There is no value for zeros after decimal point. So you will get 999, x is equal to 1. X is equal to 1 by 999. So we have converted 0.001 bar. Okay, 0.001 bar as 1 by 999. We have converted into P by Q form. Fourth question, he is asking us to change this into P by Q form. First of all, whatever given in the question will be x. So here 9 is repeating. It is actually 0.9 bar, no? 9 is repeating. So 10 should be multiplied on both sides. This is your equation 1. Multiplying by 10 on both sides. 10 into x. 0.9999, so on, into 10. You will get here 10x. Here, point will move 1 digit ahead. It becomes 9.9999, so on. This is your equation 2. Now let us subtract both the equations. Equation 2 minus equation 1. Equation 2 is 10x is equal to 9.999999, so on, and x is equal to 0.9999, so on. So on subtraction, what is 10x minus x is 9x. Here, when you subtract this part, you will get zeros. 9 minus 9 is 0. Till here you will get 0, and here 9. So there is no value for zeros after decimal point. You can neglect this part. 9x is equal to 9. X is equal to 9 by 9. X is equal to 1. Surprisingly, we got x value 1. How can you justify this answer? Let us discuss about this answer. Now here 0.9999, so on. We got the answer in P by Q, 1. We got actual answer 1. P by Q means 1 by 1. Okay. So as this is continuing, as 9999 keeps on continuing, it will reach 1. It's not ending now. So hence, this value will be equal to 1. If it is ending, we can say that there is some difference. This is continuing, means we can assume that it will reach 1. So this is the justification of the answer. Next question. What can be the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17? Perform the division to check the answer. So when you divide 1 by 17, the maximum number of digits in the repeating block can be 16. That means when you divide 1 and 17, after 16 decimals, the whole thing will repeat. Let us try and let us know through division. Let us find whether it is correct or not through division. First of all, let us divide 1 by 17. Put a point. Put a point. You can put 0. Put 0, one more 0 will come. 17 5s are 85. Subtract, you will get 15. With this point, you put a 0. 17 8s are 136. Subtract, you will get 14. Put 1 0. 17 8s are 136. Subtract, put 0. 17 2s are 34. Subtract, get 1 0. 17 3s are 51. subtract, get 1 0, 17 5s are 85, subtract, put 1 0, 17 2s are 34, subtract, you will get 16, put a 0, 17 9s are 153, subtract, put a 0, 17 4s are 68, subtract, you will get 2, put a 0, 17 1s are 17, subtract, you will get 3, put a 0, 17 1s are 17, subtract, you will get 13, put a 0, 17 7s are 119, subtract, you will get 11, put a 0, 17 6 are 102, 8 is the remainder, put a 0, 17 4s are 68, 12 will be the remainder, put a 0, 17 7s are 119, put 1 0, so here 119 means 1 will remain, we can put 1 0, so we got reminder 1, that means again it will start, again you have to put 1 0 to get 100 and this will start. Okay, again now 5 will come, 5s are 85 will come, or a whole thing will repeat again. So you can count here, you can count, this block will be repeated again, and in this block we have total 16 digits, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So these 16 will be repeating again and again if you continue the division. Got it? So that's why we wrote in the initially only maximum number of digits that repeat is 16. Got it? In this particular question, he is asking us to take some examples of P by Q form. And you should take P by Q where P and Q are integers. You can take any integers, both P and Q belongs to integers. These P and Q should have a common factor 1. Okay? Common fact, no other common factor other than 1. So they should have only 1 as the common factor. Common factor should be 1. No other common factor other than 1. It should be only 1. And when you divide P and Q, you should get a terminating decimal. When you divide P and Q, you should get a terminating decimal. You have to take such an examples. And in all those examples, what is the property of denominator you should write down? This is the question. So यहाँ पर आपको P by Q examples लेना है. Rational numbers examples. For example, first of all, know what are coprimes. What are coprimes? The numbers having only one as common factor are called coprimes. For example, I can take 5 and 8. What are the factors of 5? 1 and 5. What are the factors of 8? 1, 2, 4, 8. So here only 1 is the common factor. If the numbers are having only 1 as common factor, such numbers are called coprimes. So 5 and 8 are coprimes. Why? Because they are having 1 as common factor. So first example I am taking as 5 by 8. On dividing 5 and 8, I will get 5 6 are 48. 2 remainder, 5 2s are 16. 4 remainder, 8 6 are 48. 2 remainder, 8 2s are 16. 4 remainder, 8 5s are 40. 0 remainder. It is a terminating decimal. Okay, you should select coprimes as P and Q. They should have only 1 as the common factor. And when you divide them, you should get terminating decimal. This is a perfect example. Okay, let us take one more example. I want coprimes. So I will give you one more example of coprime. So I will be taking 7 and 6. Can I take 7 and not 6? 1 minute. Terminating decimal. No? So I will take 3 and 4. Factors of 3 are 1 and 3. Factors of 4 are 1, 2, 4. Common factor is 1. So 3 and 4 are coprimes. They have only 1 as the common factor. So I can take 3 by 4 as P by Q. On dividing 3 and 4, I will be getting 4 7s are 28. 4 5s are 20. I am also getting a terminating decimal. This is a perfect example. Common factor is 1 and on dividing I am getting terminating decimal. So one more example I have taken. Let us take one last example. So I can take 7 and 20. Shall I take 7 and 20? Let's see. The factors of 7 are 1 and 7. The factors of 20, 1, 2, 4, 5, 10, 20. All these are factors. 120s are, 2 10s are, 4 5s are, 5 4s are, 10 2s are, 21s are. All are factors of 20. And what is common factor? 1 is the common factor. According to the question, they should have 1 as the common factor. P and Q should be integer, and on dividing it should be a terminating decimal. So perfect example, 7 and 20, 7 by 20. I can take 7 by 20 on dividing. I will get 0.07. 23s are 60. 0.025s are 100. So I'm getting here 0.35. So all are terminating decimals. All P and Qs are having 1 as the common factor. Now what is the property of denominator? If you take this denominator, you will factorize. On factorizing, you will get 2 4s are 2 2s are 2 1s are 8 is nothing but 2q. If you take this as example, denominator, if you take that denominator, what is the denominator here? 4 factorized 2 2s are 2 1s are 4 can be written as 2 square. If you take this denominator, 20, 2 10s are 2 5s are 5 1s are factors of 20. So prime factorization of 20 is nothing but 2 square into 5. Got it? So in all the cases, in the denominator, you are having, on factorization, you are having only 2 and 5. In their prime factorization, 2 and 5 are present. No other number is present. This is the property of the denominator. So when you convert a rational number, if you are getting a terminating decimal, the condition is the prime factorization of the denominator should contain only 2's and 5's. There should not be any other prime number apart from 2 and 5 in the prime factorization of the denominator. In that case only we will get terminating decimal. So he's asking us to write 3 numbers whose decimal expansion is non-terminating, non-recurring. So first example, you can take 0.01, 001, 3 zeros 1, and lastly 4 zeros 1, so on. Nothing is repeated here, and it is not terminating, it is continuing. One more example, 0.2, 002, 3 zeros 2, 4 zeros 2, so on. Third example, 1.98, 988, 9888, 948, so on. And one more example, you can take any numbers randomly, 7 3 2 4 5 1 3 2 5, so on. So these are the examples of non-terminating, non-recurring decimal expansions. In this question, he is asking to write three different irrational numbers between rational numbers 5 by 7 and 9 by 11. So first of all, take 5 by 7, divide 5 with 7, 0.077 are 49, get 1 0, 7 ones are 7, 7 fours are 28. So 5 by 7 is 0.714, so on. Okay. Now take 9 by 11, get the decimal form of 9 by 11, divide with 11, put a point, 11 eights are 88, 11 ones are 11, 11 eights are 88, so on. We get 0.818. Now the first decimal form is 0.714 and the next decimal point form is 0.818. You want irrational numbers between these two decimals. So let us take 0.72. You can take 0.72, leave this 71. Don't exceed 81. You should not exceed 81. You can take 0.74, 0.75, 0.79. In between 0.71 and 0.81, you can select any three numbers. Any three numbers you can select. Even you can select 0.80 also acceptable. So these type of decimals you have to select, which are in between these two, which come between. You can't take 0.82 which come after. You can't take 0.70 which come before. You should take some decimals which are in between these two. Why? Because he is asking between the rational numbers. So let us select few. Between these two. So I am taking 0.72, 0.75, 0.79, and I want an irrational number. Irrational number have different numbers will come and it will not end. It will never end. So randomly put some numbers like 993, 9993, 99993, like this. Randomly put some numbers, or you can write 2 3 4 7 2 1 5 6 2. So different numbers you can write, or else 0 0 1 0 0 0 1 0 0 0 0 1. These are the irrational numbers between 0.71 and 0.81. That is 5 by 7 and 9 by 11. This is nothing but 5 by 7. This is 9 by 11. In between 5 by 7 and 9 by 11, we have taken three irrational numbers. Okay, so like this you can select and write the irrational numbers. Now this is an irrational number. Root 23 doesn't have any square root. It is imperfect square. All imperfect squares are irrational numbers. The decimal form of 23, if you by long division method, if you find the square root of 23, the square root will be non-terminating, non-repeating decimal. The square root will be non-terminating, non-repeating. The decimal will never end and it will not follow any particular pattern. So that's why all imperfect squares, this is a perfect square, this is an imperfect square, all imperfect squares are irrational, whereas perfect square is rational. It is in P by Q form. Okay, root 16 is 4, it is irrational. Perfect square, rational. Imperfect square, irrational. Like root 15 is imperfect, root 12 is imperfect, root 11 is imperfect, root 23 is also imperfect square. So if the number doesn't have any square root, then it is irrational. Now 225 has a square root. 225 is equal to 15. Root of 225 is equal to 15. 15 15s are 225. Square root of 225 is 15. So 15 is in P by Q form. So it is rational. The next one is a terminating decimal. All terminating decimals are rational. Why? Because these terminating decimals can be expressed in P by Q form. These terminating decimals can be expressed in P by Q form. You can remove the decimal. After decimal point, you have 4 digits. So you have to divide with 10,000. 4 zeros should come. You can convert into P by Q form. That's why terminating decimals are rational. If you see this particular bit, what is repeating? 478, 478 is repeating. So non-terminating repeating decimals are rational. We can convert these into P by Q form. So they are rational. And last bit is 0.10 100 13 zeros 14 zeros 1. What type of decimal it is? It is non-terminating, non-repeating decimal. It is not following any pattern. It is not ending. Pattern means same thing should be repeated, like 0 1 0 1 0 1 0 1. It should be repeated. Then it is following a pattern. It is recurring, non-terminating, repeating decimal. But here, one time we are getting 0 1, other time we are getting 0 0 1, again we are getting 0 0 0 1. So these type of decimals are non-terminating, non-repeating, decimals. All these decimals cannot be expressed in P by Q form, so they are irrational. Okay, so once again I'm explaining the answers. 23 doesn't have a square root. If you try to find the square root of 23, it will be non-terminating, non-repeating decimal, so it is irrational. Square root of 225 is 15. 15 is in P by Q form. All perfect squares are rational. Third bit, the decimal is terminating. We can convert it into P by Q form, so it is rational. Fourth bit is non-terminating repeating decimal. It can be converted into P by Q form, so it is rational. Fifth bit is non-terminating non-repeating decimal. It cannot be converted into P by Q form, so it is irrational.